Welcome to lecture number 15. We're going to talk about second order partial derivatives. So there are four types of second derivative or second order partials for f of x, y. And we're going to only be looking at f of x, y today. So there's the second derivative with respect to x twice. There's this, what we call a mixed partial. So the derivative with respect to y and then the derivative with respect to x. There's this other mixed partial, which is the derivative with respect to x and then the derivative with respect to y. And then the second derivative with respect to y. And we have the other notation for this, fxx, f. Now this is a little funny. It's going to be reverse order, yx. So in this notation, acting second is on the right, whereas in this notation, acting second is on the left. F, x, y. And then this will be f, y, y. So there is a theorem. I'm not going to prove this theorem. It's called Clairaut's theorem. That says if these mixed partials are continuous, then they're equal. Let's do an example. So let's compute all the second order partials. For the function e to the x times y squared minus y cubed times x. All right, so the second derivative with respect to x is going to be d dx of df dx, which is the derivative with respect to x of, well, we got to take the derivative of this. E to the x becomes e to the x, the y squared hangs out, and then x becomes 1, and the y cubed hangs out. Take the derivative again, we get e to the x again times y squared, and this goes to 0. Now we'll do the partial with respect to y and then x. So this looks like this. And like I said before, the outside derivative, the second derivative to be applied, is over here on the left. So we take the derivative of this with respect to y, we get e to the x times 2y minus 3y squared times x. And then we take the derivative of this with respect to x, we get e to the x, the 2y hangs out, and then the x becomes 1, so we get negative 3y squared. And this is where we're going to see Clairaut's theorem come into play, because now we're going to reverse the order of these mixed partials. And because these functions are continuous, we're going to see that the answer is the same. Okay, so the derivative with respect to x, we did that earlier. It's this thing, so I'll just copy that down. Don't have to think about it if I've done it correctly. And then the derivative of this with respect to y is going to be e to the x times 2y. And the derivative of this with respect to y is 3y squared. So these match. And then the last second order partial is the derivative with respect to y of the derivative with respect to y, which is going to be d dy of this thing, e to the x times 2y minus 3y squared times x, which results in e to the x times 2 minus 6y times x. And you can simplify these a bit, but that's the essence of this problem, and those are the answers.